Hello there. Welcome to the fourth section of geometrical optics. Let's look at the objectives. First is to define and explain what a dispersion is. 2. Identify the colors of white light. And lastly, differentiate and explain different kinds of spectra. What is a dispersion? Anytime we want to separate white light into 8 various components, we say we are dispersing a light. And one common optical component that we use here is the glass prism. So, anytime we pass through a white light through a glass prism, we have a dispersion of light into so many various colors, starting from red to the violet. And interestingly, the light that, or let's say the spectrum that has a longer dispersion is the one that has a shorter wavelength. So violet has a very short wavelength as compared to red, and it disperses more than the red. And I'll be adding for the practical session some experimental works that we've done to explain more. So let's look at Newton's experiment on dispersion, where a slit is placed here. So we have a white light here, a slit here, and we had a very narrowed beam here that is going to pass through a prism. All the light is dispersed here from red to what? To violet. But this time around, we have another prism here, which is what? Turned or inverted to collect all the dispersed light. And interestingly, we had our white light back here on a screen. And this one is a 2D, and this one is a 3D for you to see well how it looks like. Let's do some dispersive powers. So should in case we have a white light here that is passing through a prism, right? There are so many things here that has to be considered. One thing that has to be considered is the angle of the prism, and that is going to be our A. The second thing is to our what? Minimum deviation. That is what we have here. And in case we want to calculate the refractive index of the material of a prism, is given by this particular relation. There's a proof for this, but I think we don't have to stress ourselves on it. So the refractive index, as you already know, is sine I over what? Sine R. But this time around, we have our I here to be equals to the A, that is the angle of the prism, plus the minimum deviation divided by what? 2. And our R here, this time around, is the angle of the prism divided by what? 2. I hope you remember this. There's one common formula that we call the dispersive power. And when you say a dispersive power, the power to separate different kinds of separate light source into 8 different components is a dispersive power. And here, from the formula, we have the dispersive power to be equal to the refractive index of R minus the refractive index of big R, right? All over the average of the dispersive power of, that is refractive index of V plus the refractive index of big R divided by what? 2, which we can find the refractive index of V by this formula, and we can also find the refractive index by this formula. Is that okay? So this is the dispersive power. Let's look at rainbows. So we've all one way or the other seen a rainbow. But as to a primary rainbow and a secondary rainbow, I hope you don't know the differences. So let's look at rainbows and the formations of rainbows. So anytime a rainbow is formed, it's droplets of water that a white light has an interaction with a white light, let's say a sun. So in rainbows, there are a lot of phenomena that happens here. One is refraction, two is dispersion, three is total internal reflection. Because it's from a different medium to another medium, that is a less dense medium to a more dense medium, refraction occurs. And because this white light is being separated into 8 different components, a dispersion what occurs. And because we also have these separated colors not escaping from the raindrop, right, but reflected inside before coming out, total internal reflection what occurs. And I hope you still remember the phenomenon that I explained earlier about total internal reflection. So this is actually only one drop of water that is causing this. So look at what is actually happening here. And here, let's not confuse ourselves about secondary rainbow and primary rainbow. So for the secondary rainbow, we actually observe two reflection. That's two total internal reflection, which we can see here. So when the light rays enters the raindrop, sorry, we have one reflection here, another total internal reflection here before it merges out. As compared to the primary rainbow, we have only one reflection that is actually happening, where we have a white light that is entering, that is from the refraction, it enters, then we get only one reflection before it gets to the eye and it's being observed.